On to stage 5 now, and we're going to be implementing the echo command. So we're going to have to get a bit more involved with the Redis protocol now. Previously we were just sending back a pong when we got a ping command, and we've done some infrastructure setup so that we can handle multiple connections, responding to multiple requests on one connection. But now we need to actually deal with the input that we would get as a Redis server. So the hint for the content we're going to need to parse here, this *2 is an array, so an array with 2 elements, and this $ is the start of a bulk string. So a bulk string is saying I have 4 characters of content, not including the new line, then the 4 characters for the echo, terminated by a new line. And the same for the $3 here, that's also a bulk string. So the command here is an array containing 2 bulk strings. The first one is echo, the command, and the second value in the array is hey, which is the value for the echo command. So that's what we need to parse. Let's jump into the code and see what that needs to look like. So this is the code as it stands. We're currently handling each incoming connection on its own Tokio task. So let's pull this code that handles the connection by reading and writing values from the stream out of here into its own function, because we're going to want to add to that bit now if we're going to handle more message types. So we'll create an async function called handle connection, which takes the stream, we should be able to get that from Tokyo, and then we can just drop this in here, and we should be able to say handle connection stream. So that should work as it did before. What I'm picturing now is that we take this code that reads and writes, and instead of dealing with the Pong directly here, we'll pull out the logic that deals with the Redis protocol. So what we'll have here is something slightly higher level. So rather than having a TCP stream, what we'd like to do is be able to set up a Redis handler or something like that. So we'll have or let's call it resp handler, that would make more sense. Resp handler, create a new one of those based on that stream. And then using that handler, instead we'll call read here. And rather than just reading raw into a buffer, we'll just call read value or something like that. And that will give us back a full Redis value already parsed. So then we won't worry too much about what the result of that will look like. So we'll just call it value for now, something like that. And then we can match on that value that's coming back. So assuming that it's coming back as either an array or a string or a batch string, we're going to need to represent that somehow in Rust. What makes the most sense to me would be to handle that as an enum. So we can represent different type or different commands with different arguments in the same type so that we have an easy way to return something from read value. So we'll match on that, and then in here we'll say something like to do handle echo and ping, and that will give us our response back. And then we can ask our handler to write that response value back. So it'll be write value now instead, and we give it this response. So something like that. So most of the work for this task is figuring out how to make this thing work. So making this parse the input values, give them back to us in a way that we can match on them and make a decision about what to send back. And then again, serializing them back to the Redis text protocol. So let's make a start on building a new module for this resp handler. Let's start by defining a struct to represent the resp handler we were using in the skeleton code in main. So we'll do pub struct resp handler. So the first thing that needs to hold is the TCP stream. And we can get that from Tokyo. And then the other thing it'll make sense for this to hold is the buffer that we're using for reading from the stream, so that we don't have to recreate that every time. It'll live as long as the handler does. So create a buffer. And we could define this as a reference to a byte array. But to do that, we need to introduce lifetimes, which we've then got to have through the resp handler, through its implementation. So the easiest thing to do is to use one of the provided dependencies, which is bytes, which gives us a byte array that's got interior immutability, so we don't have to worry about holding a reference to it. So we'll just use the bytes mut type here, and then we can import that. That comes from bytes mut. Should be the type, I believe. Cool. So that's our basic type. Now we need to give it some functionality. So let's implement it. So first thing we need is a constructor. Take a TCP stream, and we'll return self. And that will just be a resp handler of stream, and then the buffer will be a bytes mut with capacity, and we'll use the same size as we used for our previous buffer, which is 512 bytes. It's not really a well thought out value, it's just enough for this exercise, and you could pick a better value for this, but it's good for now. Then the other two things we need this to do are reading and writing values. So let's create some functions for those. So we'll define a read value function, which will need to mutate the buffer. So it needs to take self mutably, and that will then return, I guess, a result of a value type that we haven't defined yet. So let's just quickly put something in so we can work with something. Define an enum called value for now. That will do. And then we'll fill this in with a to-do, read from socket, and parse. And then similar for the write, we'll also need to, will it need to read from the buffer? No, but it needs to be able to write to the stream. So let's take self mutably. That can also return a result, but it won't have a value because we're just doing a write. It will need to take a value though. So we'll take a value of type value. Again, we'll just fill that in with to do, serialize, and write to the socket. Cool. Okay, so that gives us a skeleton to work with. The next thing to do now is figure out what things we need in our value enum. So let's jump onto the documentation for the REST protocol and have a look at what we're going to want for that. This is the Redis website, so the official documentation. And I'm looking under reference and protocol spec here. So we've already seen simple strings, so we know we're going to need to support that for ping pong at least. So these are a plus followed by some text that is not allowed to be binary safe. So it's just ASCII characters with no new lines in it. And then a new line to terminate. The other thing we know we're going to need from the hint on the CodeCrafters information for this exercise is arrays and bulk strings. So if we have a look at arrays, these are a star character followed by the number of elements in the array, which is a number, just a decimal number, and then the number of resp types that we expect for that number we were told for the array. So it could be a number of simple strings, it could be a number of bulk strings, it could be anything that parses as a resp value. Just we are told the number, that's all we know. So that's simple enough. And then the last thing is bulk strings, which are a $sign followed by a number telling us how many bytes there are in the string, and then a new line, then the data, and then another new line. So we have here $5, new line, 5 bytes, which is the hello, and then a new line to terminate. So those are the 3 things for now that we care about parsing. So let's jump back and make a start on parsing those. Now we know the types we need to handle. Let's go ahead and add those to our value enum. So we'll add simple string, which can just wrap a string. We'll add bulk string, which will also wrap a string. So the difference is just their encoding. They do actually both hold a string. And then we also know we need to be able to hold an array, which will be a vector of the same type. So it holds more values of the same type of some length. So then probably the first thing we should do just so we know what the representation looks like as we look back at this, is implement the serialization. So before the parsing, we'll just work out how to write these back as text. So let's implement the enum and add a function to serialize it. So we'll serialize back to string. We could serialize directly to bytes, but something else can convert that into bytes because a string in Rust is just bytes anyway. So easy for us here. Match self. And we can then do value simple string, which will contain a string, and that will convert to, just use a formatter, a plus followed by the value, followed by new line. And then we can format in the string. There we go. I don't think we need to borrow here. We can just consume value because we've already taken it without a reference. And then we can do value bulk string. Format. And this will be a $, followed by the length, followed by a new line, followed by the content, and another new line. So the length we can get by doing get the characters from the string and get the count of that, because that gives you back a character iterator, and then format in the string itself. There we go. And then the other values we don't actually need to be able to send back. So array we don't send back, and the other types that Redis supports, like integer and error, we're not going to support those. So we will just say anything else, panic, unsupported value for serialize. Cool, okay. So that's probably the easy bit. Now we need to figure out the other way around, which is parsing things that look like this, and also parsing arrays, because although we're not going to send them, we do need to receive them. So let's try and tackle that bit next. The first tool we're going to need for parsing is something that can read up to new lines. So because the protocol is all structured around this \r\n, we're going to write a function that can consume text up to that. So that's going to give us an easy way to chunk up our input. So it's not the most elegant way to do this, but it's very effective. So let's give it a go. So read until control line feed. So, not control, carriage return. So carriage return, line feed being the names for \r and \n. So we'll take a raw buffer here, which will be a byte array, and we'll return if we match something. So optional, the content we matched, so that will be part of that buffer, not necessarily the whole thing, and the amount of that buffer that we read, which will be a usize. So the reason to capture only part of it is that we won't be reading the whole input string. So we'll say, tell me the part of this buffer, or tell me the part of this whole buffer that you read while trying to look for a line feed. So that we can do this multiple times within the same input message. So let's run through the characters in the buffer. And then we're going to say if the previous character and the current character are new lines, so \r and \n separately, then we find a match. So let's say if buffer at i-1 is \r and buffer at i is \n. And I think because we're reading out bytes here, we need to tell it that these are bytes, not strings. There we go. Then we can return sum of buffer from 0 up to i-1. So we're saying that we want to read the content that came just before that. So just before the \r. So we want to include from the very beginning of the buffer we were passed up to just before the \r character. So we'll ignore the \r and the \n and the value we return. And then the length that we return will be i +1. Whoops, +1. There we go. And then if we don't find anything by the time we get to the end of the buffer length, sorry, that's not correct, buffer.length, then we return none. Okay, so that's our basic tool. So now let's come back up to the top level and start thinking about how we parse from the top level. So for that, let's define a function called parseMessage, and that will take the full byte buffer. So we'll take bytes mut here, and that will give us back a result of a value and a usize. So if I want a tuple here, I need to wrap this. Okay. And then we need to look at the first character in the buffer to work out what type of message this is, because there's always a character like a dollar or a star or a plus. So we will match on that. Match buffer, read out the first thing as a char, so we don't have to type in bytes for each thing. And then we will read plus for simple string. And then we'll have a function for that, parse simple string. And we'll pass the buffer off to that. And then a start for an array. Pass the buffer into that as well. And then a dollar will be a bulk string. And pass in the buffer. Anything else, we don't know what it is, so we'll just return an error. So I'm going to use anyhow for that. Not a known value type. And then try and make it easier on ourselves by formatting in what we got. I'm not sure how you convert a buffer to a string. I'm going to have to look that up in a second. So that should do for now. If we return that, we can wrap. Actually, we don't need to. So each of these can return a result as well. So these will return a result. This is explicitly returning an error value. So that should do. So let's try and build one of these. Let's start with simple string. That should be the simplest to parse. So let's go from there. So let's just copy that name. Find a function called the same thing. This will take our buffer. Just copy that type. And it's going to need to return a result. So it can pass or fail. It may or may not find a simple string. So let's wrap that in an option. Or is that true? So if we see a plus, no, I don't think that's true. If we see a plus, let's assume we always have the whole input, and we will be able to parse a string from that. So that will just return value and how much we consumed. There we go. Okay, so then we can use the thing we've already built, this read until control line feed, to say if let sum equal to read until control line feed, pass in the buffer, and we're going to slice it from 1 onwards, and we will borrow that, not move it. So what we're saying here is skip the first byte, which we already know is a plus, and pass whatever's left as a raw buffer into this read until control line feed. So that will give us back either a sum or a none. If it's sum, it will be a tuple that has the content we care about. So we'll just call that line, and a length, which is the amount of data we consumed. So if that worked, then we need a way to turn this into a real string. So the way we do that will just be string from UTF-8. And then we'll pass in the line, and that needs to be unwrapped somehow. It gives back an error. I can't quite remember how. Again, I'm going to look that up just now. So let's just then say that gives us back a string. And then we can return this. Return OK of value simple string. Pass in our string. And then the second value of our tuple that we're giving back, let's turn this into a proper tuple, will be the amount we consumed. So that will be the amount of data we read in the control line feed function plus 1 for the plus that we skipped. So len plus 1. I'm just going to quickly look up how we do a from UTF-8 with bytes. Okay, these are the docs we need. So this is the string documentation, and it has a from string, or from UTF-8 even, to create a string. So it takes a vector of bytes, not a slice like we currently have, and it returns a result that contains a string or an error. So now we know what it should look like. Let's jump back and make a change to our code. Okay, armed with that knowledge then. So our line is a byte array, so we can convert it to vector like so, and then we can just unwrap the error because it's not super important right now. And now we have a string. And helpfully I've also figured out why my IDE autocomplete wasn't working, so we have some more hints. This should now work. If we don't manage to parse a string when we found a plus, let's return an error here. Return error, anyhow, and we'll say invalid string. And let's just pass back the thing that got passed in as a buffer. And again, I haven't yet looked up how to convert that properly into a formatted string. I'm hoping it has a toString on it. If it doesn't, the compiler will tell us. Cool, so that is parsing simple strings. We still need to deal with arrays and bulk strings. So let's do array next. Actually though, we're going to need another tool before we can handle arrays, which is taking the number that comes out of the array input. So when we're reading an array, we get star, number, and then new line that tells us the number of elements in the array. So we're going to need to be able to convert those bytes into a number in Rust so that we can work with it. So let's do a parse int function that takes a byte array, u8, and that will return a result of I64. And then the easiest route for us to convert from bytes into anything is to go via string. So if we do a string from UTF-8, that we did before, and we take the buffer to vector, we can return the error from that directly, and then we can call parse on it. And the compiler might be smart enough to match up the parse with the return value here, but let's just tell it that it's an I64, just to be sure. And then we can start defining our array parse function. So let's do that. And it's going to be a little bit similar to what we did for parsing simple strings. So we'll take that as a starting point. So it starts with a star, our parse array. So we can do the same thing here, which is to say read until control line feed, skipping that first character, which we know is a star. That will give us back a line which will contain the count. So let's ask for a parse int here of the line and bubble up any error if there is one. That is giving us back a very weird type. So result I64 unknown, try output. That is probably because result isn't defined yet, and that is because I've forgotten to import it. So anyhow result, will that behave better then? Good, so now it's saying that's an I64 like we expect. Looks more sensible. So that is giving us, so we don't want to return here anymore because we've got to carry on working. We want to give a value out of here that says array length, which is what that thing should be called. And then we've still consumed length plus 1 bytes. So same as we did above, that's how many bytes we've consumed by reading star, number, new line. So we'll continue parsing from there. So we'll say let array length and bytes consumed equal to that thing. If that doesn't parse correctly, then our input was bad, so we'll just return an anyhow error. Anyhow, sorry. And that will be invalid array format, something like that. And we'll try and give back again the whole buffer that we were passed. Okay. That looks good. So now we can start thinking about how do we build up the output value here. So we're going to want to keep reading from this buffer, updating the bytes consumed every time we read something, and we expect to get array length number of items. So we can say something like for don't care in 0 through array length. And then we can parse each thing one by one. So we'll say parse, and then our top level thing, parse message. Pass in the buffer, and we'll have to construct a new bytes mut here from what remains. So we'll say in our buffer from bytes consumed onwards, and we'll have to pass that as a reference to construct from. So bytes mut is basically going to just manage that reference to that buffer. And then we will bubble out any errors. What does that thing return? Just a value. Okay. So we can say then let array item and length, just call that len because that's what we've called it everywhere else. That's the number of things that are newly consumed. Okay, so we've consumed some more items. We want to then update our current position in the parse. So let's just say bytes consumed increments by length. We'll have to make that mutable. And then we also want to store this array item somewhere. So let's declare somewhere to keep those. Items is a vector. We can just declare one like that. And then we can do items.push array item. There we go. Okay. So that will build up our vector of values to go in. So then at the end, we should be able to just return OK of value array and pass in our items as the value for those. Is that good? Not quite, because we have to pass back a tuple that tells the top level how many bytes we've consumed. So let's just remember to return bytes consumed there. And that should be good. So that is arrays. We'll have to check it to make sure it works. But there's one more thing to do yet, which is to parse bulk strings. So let's do that next. Okay, last bit now with bulk strings. So as a reminder for what they look like, they're a dollar followed by a number, which is the number of bytes in that bulk string, followed by a new line, followed by the actual bytes, followed by another new line. So in structure, they are somewhat similar to an array. So we'll start from that code, and we'll grab the name for the function we're trying to build. Okay, so we can start off the same way, reading up to a control line feed, ignoring the first dollar in the string, and then again we want to read a length out, so that's useful. It's just not array length anymore. We'll call that bulk string length, and that needs to be renamed in the outer as well. There we go. It's still useful to have bytes consumed, but we aren't going to be doing anything iterative here, so it doesn't need to be mutable anymore. And then all the code down here to deal with actually creating an array, we don't need. So it's probably easy to think about what we want to keep and throw away up front. So let's define some new variables. So we're going to say let start of bulk string. Well, actually we don't need the start of the bulk string. We know it starts straight away, but we need to know how far we want to consume. So let's say end of bulk string, and that will be the current position, so bytes consumed so far, plus the length of the bulk string that we've been told by our input. And then, is that right? Which thing is coming up as a, that's an I-54, that's a U size, all right, okay. So we want to convert that so they're both the same type. Cool. And then we also need to know where we're going to have parsed up to. We don't actually need to parse this as such. We don't need to run through that whole byte string and make sure it's there. So we can just say total parsed or something like that. That will be end of bulk string plus 2 to read the \r/n at the end. So now we can try and construct our output. So this will be an OK of a tuple containing value bulk string, which will then be reading into our buffer. So this should be, well, we need to convert to a string. That's the first job, don't we? So from UTF-8, there we go. And then we need to select part of our buffer out. So we'll do that by saying take buffer from bytes consumed. So basically from the start or from the end of the new line after the number of bytes in the string from our input, all the way up to end of bulk string. And that's not happy because I deleted the ending bracket. Cool. And that then needs to be converted to a vector to be passed to that. We can bubble up the error from it. That's then our bulk string value. And the other thing we need to pass back is the total parsed, so how much did we consume as part of this function. So that is all the pieces for our parser. Now let's see how close we are to putting it all together. So coming back up to the top level, we've still got a to-do for handling our echo and our ping. And if we drop into the handler as well, which I haven't actually imported, so let's make sure that's here. That's the rest mod. Just reference that directly for now. So if we drop into the read, that actually hasn't been implemented yet either. So let's figure these bits out first, and then we'll come back up to main and make that bit, make use of those values. So here we want to take our stream and try and read from it. So we'll read into self.buffer, and the IDE's helpfully made that mutable. And then we can await that and return any error we get. Good. So that will then be bytes read. Cool. Now we are going to have to handle the same thing we used to in main for that code isn't there anymore. So the thing we were handling in the previous stage for saying if we read no bytes from the socket, then the socket's finished. So it might actually make more sense to return an optional value here. So we can say option value. So if bytes read is empty or is 0, then we return OK, that's not a problem, but you didn't get a value, so OK none. Otherwise, if we did read some bytes successfully, we can say parse message, passing in self.buffer for it to read from, sending any errors back, and then we can say let v for value equals that, and finally we can return OK sum v as our final result. Not quite, so we need to throw away the size. So the size is useful internally for the things like arrays. So if like a bulk string didn't give back the length, an array wouldn't know where to stop parsing, so that wouldn't work too well. Or wouldn't know how to like continue parsing, so I should say. So like it wouldn't know how much it had read every time it parsed a bulk string within an array. But at the top level, we don't care all that much. We'll just assume we parsed the whole input. This isn't happy because we are moving out of buffer. We don't want to do that. There's a method on buffer called split, which basically just passes a read-only view of the buffer. So that will solve that problem. Okay. And then for writing the value, this should be really simple. So we can just say self.stream.write. And then we want to pass in the value serialized. We already wrote that earlier on. So that is this thing up here that takes it and converts it back into a string format. So that gives back a string. And we can say turn that into bytes, please, which already is under the hood anyway, but needs to be converted. Wait for that to be sent, and that will just error if it needs to. The only thing we don't really want is to give back the actual value. So let's just say do that and then return OK empty. Cool. All right. So that's our read and our write. So now we can come up to main and make use of that. All right. So we're in pretty good shape here. The last little bits to do are just to figure out this match block now. So I'm going to start by clearing out some of our warnings. That doesn't need to be mutable anymore. Buffer isn't even used because it's been moved inside the RESP handler. And then we're just on to errors. So we're going to need to unpack the value we're being sent. So although, yeah, it's coming back as a Redis value, in order to actually turn it into something we can easily work with, we're going to want to change it a little bit. So let's say rather than matching here, we've actually got an option value. So we can say if let sum. So if it matches our value, we want to process it. Otherwise, we need to stop. So because we know from the read value, if it gives back a none, then we're finished. So if we get a none back, we'll just break. And then our response, it doesn't know the type yet, that's fine. So to extract this, I've copied and pasted in the format we're expecting. So we're expecting to get an array that has the command values in with an echo and a value. So it's like a command string followed by its arguments. Let's assume that's the format we're always going to be passed and just break that down. So we want to try and take a value and extract it from that format into something we can easily work with. So I would like the command as a string that I can reference directly in code, and I would like the args ideally as a vector that I can work into, something like that. So let's do extract command, which will take a value coming from resp, and it's going to give us back a let's do a result, and that will contain a command string and the arguments. Cool, and then let's not make the same mistake again. Let's make sure we have our types imported. So we'll use anyhow result, and I think that's the only one we've been missing there. Right, so extracting a command will match the value and say if our value is an array, then we have an array, and we can take items out of the array to build our result type. So we can give back OK, and then the first value will be a string. So we can say, well, deal with that separately. Let's just say a.first.unwrap initially, so that will give back a value, which is not what we want. We actually want to turn that into a string. And then we want to take the rest of this thing. So we'll say a.iterator. I think I can convert it into an iterator there. Skip one and collect. So that will then give back our vector. And otherwise, if it's not an array that we get as input, we'll just return an error. So anyhow, unexpected command format. So we don't yet know what format the echoes are being sent in, or the pings are being sent in. Sorry, we do know the echo, we don't know what format the pings are being sent in, but I'm just going to assume it's this same format, and if it's not, we'll just deal with that. So this thing is not quite right, we're getting a value reference, not a string. So let's just do unpack bulk string or something like that. Bulkster. And that could just be a value. I'll give back a result of type string. So again, we'll just use the same trick to match this and say if it's a value bulk string, because that's what we're expecting inside our commands here is a bulk string. S, then we just return OK S. Otherwise, if it's anything else, we'll just say something similar to this. Expected command to be a bulk string. Good stuff, so at least we know if it fails what went wrong. And then we can say unpack bulk string around that, and that will probably need to be copied to make that work nicely. And we will need to return the error. Not quite. Value doesn't implement clone. Okay, cool, so we can easily fix that. So we just need to derive clone on here. And that should sort that error out. It does. Good. Okay, we're getting somewhere. So now we can say extract command on this value v, let command comma args equal to that. Then we can, not quite, we need to unwrap the error here. So we could bubble all these errors out so that Tokyo can handle them and they're all held in one place. That would clean things up a little bit, but let's not do that for now. So we'll match command.addString so that I can type in raw values. So I'll say if we get a ping, then return a simple string of pong. And we don't need any syntax this time because it's going to convert that for us. The simple string already knows how to encode properly to our network value. But we do need to convert that to a proper string. And then we can say, otherwise, if it's an echo, we convert that to a value of what do we want to send back? Simple string or bulk string? I'm not sure what this should be. Let's just say bulk string to return it the way it came to us. And then we want to take args.first, unwrap and copy. That is not happy because expected string found value. Oh, fair enough. Well, actually, we don't need to do anything then. Let's just take the arg we were passed directly and return it. Okay, and then anything else, we'll just do panic here, cannot handle command, and we'll format in the thing that causes the problem, which was the command. All right, cool. So that should more or less function now. I think we just need to worry about some errors in here, which is complaining about. It's complaining about our buffer not being in the right format. For the moment, unless we need to debug this, I'm just going to put in debug strings here. So these will get printed out, I suspect, as raw buffers, which is not super useful. But unless we need to debug it, not a big deal. And then this thing's not happy. All right, fine. In that case, we need to just convert the errors. So we'll just do a little trick. That should sort that out. Cool. So our project should now build. Let's give it a test and see how it does. So how do we do with a build? Not too terrible. A couple of warnings, but we can fix that easily enough. May as well get rid of those. So that now builds without warnings. So we should be able to build this. CodeCrafters test, or test this, sorry. All right, we have broken previous stages, which is not too surprising, so we've made pretty big changes here. So connection reset by peer, that just means we've dropped this connection without holding onto it to read and write back to it. So something is definitely wrong here. Let's put in a quick log line. So say here, starting read loop. Let's also log what we received to make sure we're getting something sensible. Got value, and we'll debug print the value we got. We can't do that at the moment because debug is not implemented for value. We can fix that by deriving it. And then let's also print out the response that we're planning to send back to make sure we're getting this far. Sending back a value of response. Okay, let's see what happens if we run the test like that. Okay, nothing. So we accept a new connection, then we never make it as far as starting read loop. There's not too much between these. We construct the resp handler, which doesn't really do anything, it just constructs a new value. Ah, okay. So when we call handle connection, that's now an async function. We need to actually wait for that to finish. So if we await that, that should help. Okay, slight improvement. So starting read loop, got value none. So that is this log line here saying we didn't get a value. That came from handler read value. And the only way we get a none back is if we receive 0 bytes from the network. So this one, I have a pretty good idea what's going wrong here because it's burned me before. So we've declared a buffer with a capacity. What we haven't actually done is initialize that buffer. So what Tokyo sees when we pass a mutable buffer here is an empty buffer. So it's basically saying, I couldn't read anything from the network because you gave me an empty buffer, so it's full, or so I can't write to it, however you want to think about that. So there's another method on Tokio stream read, which is read buff, which will expect a potentially uninitialized buffer, and it'll treat this as like a, well, basically as it is, like an interior mutable reference to bytes. So let's try it like that and see if that behaves better. Much better, wicked, okay. So everything up to stage 5 passes. So that is all we were hoping to achieve. So I can push that up now, and that will be the end of stage 5.